Hello, I'm Aaron Park, and this is 7th grade, lesson 33. So for our first problem, there are 50 apple trees in the orchard. They are arranged in 8 rows. X trees are in each of 7 rows, and only 1 tree is in the last row. What is the value of X? So these problems are similar to ones we did last week, where we have a total divided into a certain number of rows or groups or whatever, but one or more of the rows are different. In this case, the last row, one row, only has 1 tree, and the other 7 have X. Now, the total is equal to the sum of the parts. A simple concept, 1 plus 2 equals 3, 1 cookie plus 2 cookies is 3 cookies. Similarly, X rows of trees of an unknown number, 8 rows of trees of an unknown number is equal to the total 50 trees. Now the thing is, it's not just 8 rows, it's actually 7 rows of X and 1 row of 1. So how do we write that? Well, we have 7 rows that are each X, 7 times X, plus a separate 1 row that is 1. 1 times 1 is just 1, of course. So we can get rid of this constant by subtracting 1 from both sides. This cancels out, leaving us with 7x is equal to 49. We divide by the coefficient of x to isolate it to give us x equals 49 divided by 7, which is 7. X is equal to 7. The answer is B. Now for number 2, solve for x in the expression below and mark the correct answer. We know how to solve for variables, hopefully. This time it's just throwing us up with fractions and decimals. Well, there's 2 ways we can go. The first way is just go through it normally. First, we want to isolate the term with x, which means we need to get rid of this constant. In order to cancel out our minus 1/2, we add 1/2 to both sides to get 0.25x is equal to 1.5, which is 3/2. Now, we want to isolate the x itself, so we divide by its coefficient of 0.25. The thing is, that's a decimal, which is a little bit nasty to divide by. But using what we know about decimals, we can instead treat it like x over 4. 0.25 is 1/4, so these are the same. In which case now, to isolate x, we multiply by the denominator. So we multiply both sides by 4. The 4's cancel here, leaving us with x. Cross cancel, dividing by 2, leaves us with 2. 2 times 3 is 6. X is equal to 6. Now the other option is, if I could just clear the screen, if you don't like working with all these fractions and decimals, we can get rid of them. First, we need to convert the fraction into a decimal. 1/2 is the same as 0.5. And then now we can multiply both sides by 100. We're allowed to do this because we're doing it to both sides, so it doesn't matter. If we multiply 0.25x by 100, we get 25x. You can think of it as multiplying or moving the decimal point right to. Similarly here, minus 50 equals 100. Now we just do the same as before. We add 50 because that's the constant. Then we divide by 25. And you will get the same answer. X is equal to 6. Now, for number 3, Cole pays $20 per hour each for his 2 workers. This week they worked 40 hours and X hours each. Cole pays them $1,200. What is the value of X? Let's take number 1. We have a total and some parts. So the total amount of money is $1,200. Now, what are the parts? Well, we can see that he pays them $20 per hour, so we just need to find some hours. And what would you know? There's 2 hours here. One is 20 times 40 hours, and the other worker must have worked 20 times X hours. So we don't know how much the second person worked. But we know how much the first person worked, and we know Cole pays $20 per hour, and he paid $1,200 in total. So we could multiply this out to get 800, subtract 800 from both sides and divide by 20, which would be perfectly fine and you would get the correct answer. Or you could divide both sides by 20 from the start. This will make our number smaller and easy to work with. 20 cancels with the 20s in the numerator. And here, 1,200 divided by 20 is simply 60. This leaves us with 40 plus X is equal to 60. We subtract 40 from both sides to get X is equal to 20. The answer is A. I'll leave the rest for you to do on your own. Let us move on to factoring. We are asked to factor the expression. So when you factor, as the name suggests, you're going to take a common factor from the terms and move them outside. The inside, whatever's left, is in parentheses. For instance, at 2x plus 2, we could factor out the common term 2, the common factor 2 from each term, which means the 2 goes outside in parentheses, and inside the parentheses we're left with what's left. 2x divided by 2, because we factored out the 2, is x, plus 2 divided by 2 is 1. This is called factoring. Now, as you can see, it's going to be a bit more complicated than just factoring out a constant. You want to look for common factors, which means some factor that both terms share. For our first problem, you should notice right off the bat that they both have an x minus 8. This is what we are going to factor. So you write what you factor, and then in parentheses, being multiplied with it, you write what is left. How do you know what's left? Just divide the term by what you factored out. So x times x minus 8 divided by x minus 8 is x, plus x minus 8 divided by x minus 8 is 1. You have successfully factored the expression. You can do the same for the rest of these problems. You'll note that most of them have this very obvious factor. All you have to do is make sure you write the terms correctly. That's all for today. Thank you.